Hi guys, welcome to this video. So today we will solve one more LeetCode question. This is for binary tree. So let's understand the question first. So this comes under easy. The question number is 226. The question is, given the root of the binary tree, invert the tree and return its root. So what it is saying, so we need to invert the binary tree. So how we need to invert? So if you see over here, let's take the simple example first. So if you're seeing here, this is a binary tree, it's having two child, the root is 2, the left child is 1 and the right child is 3. So once you invert it, so it's a kind of mirror image. So if you invert, or you can flip like this from this to this side, then the root remains. So if you invert it from here or rotate it from here, then 2 remains as it is. So 3 becomes the left and 1 becomes the right. So let's look at the bigger binary tree. So if you see, if you flip it from this, if you have an imaginary diagonal line over here, then if you rotate it, so 4 remains at this, so this gets rotated, so 7 at the right becomes at left and 2 becomes here. Okay, now if you rotate it like this, so this leftmost one comes to the rightmost one, then 3 comes here, and then 6 comes here, and 9 comes here. So if you add a mirror, I think so it will be the inverted image. Okay, so let's look at the constraints. The only constraint what we have is the number of nodes is in the range of 0 to 100, and the value will be from -100 to +100. How we can solve it? So first thing is, like, this is a binary tree. Usually any tree question, any binary tree question, you can solve it recursively. It will be much easier to solve it that way. Okay, let's understand, or let's focus in that area first. So suppose this is a binary tree and I have to invert it. So if you want to invert this, what exactly we need to do? So what we are doing, we are interchanging the left and the right subtree, right? Left and right child. So 2 remains as it is. So the left becomes right and the right becomes left. So this is what we are doing. How we can solve this in a bigger tree? So in the bigger tree also we can do it recursively, but we need to think about from where we need to start. So there are various ways. You can start from the root and you can keep on flipping the childs, or you can go deep down till the last node where you have the right and left as null, and then you can start flipping from there. Okay, so if you come from left, then you come here, then you flip this. These both are null, so if you flip it, it remains the same. You traverse back here, then for this as a root you can flip this, right? Once it flip, you go back here, and then you go back to your root, and then right, you can perform the same thing. So for code, for these type of code is really easy. We will write exactly what we have spoken. So we will go to the all the leaf nodes, and then we will start flipping it. Okay, so let's write our code in Java. So as a first statement, we will write, if our root is null, there's nothing we can do, it's just return null. Okay, now what we will do, we will go till the left. Okay, so what we can do, we have tree node, and we will call this recursively to root dot left. Okay, we will keep going to the left. Now we need to do the same thing for right. Once we came to the left over here, right? So suppose we are over here, we did root dot left. Our root is 4, then we did root dot left. So now we come over here, so our root became 2. Okay, Now this is not null, then again it will go to root dot left. So root dot left is 1, right? We come over here. Now again we will go for 1, so my root is null, right? Now for this it's left, it becomes null, so we will return the null. So here we will have null value. Okay, now since we have null over here and my root is here 1, okay, so its left is null. Now we will come over here. For 1 we will do root dot right. So root dot right is null, so it will come over here, so it is null, so it will return null to me over here. So now my left and right both are null. Okay, so either you can add, like if it is both null, then return the root. I think it is not needed. We can just simply do root dot left, we will add the right, irrespective of that it is null or not, it will not make any difference, and root dot right equal to left. Here we are not using any temp because you already have two variables, so we don't need that, and we will simply return root. Okay, so for 1, since left and right both are null, so it will interchange and it will return the root, so it returns my 1 to here. Okay, now this is my 2's left, right? So my 2's left, if my root is 2, so 2's left will return me 1, right? Now if it returned me 1, so here it will become 1, my root is 2. Okay, so this is my left. Now we will go to 2 dot right. Okay, so for my 2's right, so my 2's right will, here it will return 3. So if you can go recursively, you will find like left and right both null, so it will return the root, so it will return 3 to my 2 as a root. Okay, now 1 and 3 I have, so 1 and 3 what I will do, I will interchange it. So root of left, so my root of left where I am having 1, I'll place my right with, that is 3, and root dot right where I am having 3, I'll place my 1, so it will interchange, and again I'll return my root. Okay, so I'll return the 2 to my 4. Okay, similarly the 4 will flip to this, because it will not be bothered about the child below it, because it is flipping only its immediate child. Okay, so it is not bothered about all the child below it. So 2 has taken care of 1 and 3, now 4 will take care of 2 and 7 only. Similarly 7 will take care of 4 and 6 and 9. Okay, so every parent will take care of its child, and recursively we will move to root. Okay, so let's remove these comments. Let's try it out. So our test case is solved, and let's submit this. Yeah, so it worked. Hope you understood this question. See you in the next. Thank you.